Good day again, everyone. This is O'Shane, and today we're going to be talking about writing linear equations. But most specifically, we're going to be talking about the best practices for writing linear equations. So, we're going to go in a specific way, right? So, what I want us to focus on is the instructions for each section, and I'll talk about that when we get there. So right now, the instruction says write the slope-intercept form of the equation of each line given the slope and the y-intercept, right? So with that being said, we want to remember what the slope-intercept form is. The slope-intercept form is y is equal to mx plus b, okay? Now, where m is your slope and b is your y-intercept. So what this means is that if I'm asked to write the slope-intercept form of the equation of a line and I'm given the slope and the y-intercept, it's pretty straightforward for me to do so. So let's take a look at it. The first one says the slope is -4/3 and the y-intercept is -1, which means that this is your m, this is your b. So in a very straightforward way, I would say y is equal to -4/3x. Well, we could even say plus -1, right? This is mx plus b, right? Now, pretty straightforward, just as we're understanding that we're writing the slope-intercept form of a line, the most two basic things that we need are the slope and the y-intercept. So there's a reason why I started here in relation to best practices. So with this one, number 2, y is equal to -4/3 x plus 3, right? So if I'm given the slope and the y-intercept, then what we're going to do is we're going to write the equation of a line using slope-intercept form. So what I want us to think about here is just remembering that if I'm asked to write the equation of a line, if the question says, hey, write the equation of a line, right? And I'm given the slope and the y-intercept, then it means that the form that I would really want to use is called the slope-intercept form. That's important, right? Now, let's look at this example here. Our slope, m, is 4, and our y-intercept, b, is equal to 0. What does that equation of a line look like? Well, remember, y is equal to mx plus b. It will simply be y is equal to 4x plus 0, which means that y would be equal to 4x. Okay? That's just something to note. Similarly, if our slope is 0, then mx would be 0 times x, right? Something to note there. Now, let us focus on a different form. We're going to be looking at writing the slope-intercept form again of the equation of each line. But what's happening now is that we're given a graph. Now, this is a little bit more tricky because I have to be able to identify what my slope is and what my y-intercept is, right? Remember, if I'm doing the slope-intercept form, which is y is equal to mx plus b, the two things I need are my slope, m, and my y-intercept, b. Let us look at number 6 together. So from this graph here, the first thing I want us to be able to recognize is that I can always identify my y-intercept by looking at wherever this function intersects the y-axis. That is right here, okay? So what we can assume is that our b is equal to negative 4, right? Typically, your y-intercept is going to be the easiest thing to identify. What we now need to do is we need to identify our slope, m. And this is one that's going to be a little bit trickier, but I would like you to follow what I'm going to do. Now, the first thing I'm going to do is, based on our previous lesson, I'm going to look at three things. I'm going to look at whether my slope is positive or negative. I'm going to count the rise, and I'm going to count the run. So three things: one, two, three. Okay. Now, let us look at whether this function or graph is positive or negative. As you can see, if somebody is going to be walking up this hill, they're going to be walking up the hill and they're going to be walking in the negative direction. So the first thing we're going to assume or understand is that our slope is going to be negative, right? Now, when we're counting our rise and our run, what we need to do, specifically in this case, is we need to find where our graph intersects what we call lattice point. So what that is somewhere at vertices of one of these squares. So we already have one here on the y-intercept, and look, follow along this line here, and you'll realize that there's a lattice point right here. All right. So when I identify my lattice point, what we'll then do is we'll create this right triangle here. And now we can count our rise and our run. Now that we understand that the function is going to be negative, we can just simply count regardless of direction. So let us count. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So the rise is 8. And let's count the run. 1, 2, 3. And the run is 3. Okay. Now, I believe that as a best practice, if you do it this way, you cannot run into any errors because you're doing it fundamentally, right? By analyzing whether the function is negative or positive first, and then counting your rise over your run. Okay. Now, now that we have our slope and our y-intercept, we can say that the equation of the line is y is equal to negative 8 over 3 x plus negative 4. And these two, the positive and the negative, will become a negative, but I just wanted to fundamentally put plus negative 4 there first. Okay? Now, let's look at this one. I put this example in here specifically because just to see if you guys remember what we spoke about in our previous lesson. What kind of line is this? Well, this line is a horizontal line. And what did we say about the equation of a horizontal line? Well, the equation of a horizontal line is always going to be the line y is equal to a, right? Always remember that because it is intersecting, this line here is intersecting the y-axis. Okay, just remember that. So line y is equal to a. What is a in this case? Well, a is wherever it is intersecting the y-axis, and it is intersecting the y-axis at -1. So the equation of this line is just y is equal to -1. All right, that's just one thing I wanted us to remember. Um, let's look at a few more examples here really quickly. Okay, so let's do this again. Let us analyze where our y-intercept is. Our y-intercept b here is going to be 4 because as you can see, the function intersects the y-axis at 4. Okay, great. Now that we've got that part, let us find this slope. Now we can see that it's sloping in the negative, so we know it's going to be negative. Now let's construct our right triangle. If I put there at that lattice point, then my right triangle looks like that. Let's count our rise. 1, 2, 3, 4, 5, 6, 7, and the run 1, 2. So now I can say my function is going to be y is equal to negative 7 over 2 x plus 4. And that is the equation of the line. Just to remember to write the equation of a line in slope-intercept form, y is equal to mx plus b. The two things I need are my slope m and my y-intercept b. Okay? And from a graph, we can identify that by analyzing the y-intercept here, which is 3, and analyzing the slope. Here's on a lattice point, here's 1. You see that? Here's 1 again. So anywhere we draw the right triangle will give us the correct slope, right? Rise, this function here, we can tell is positive because it's sloping in the positive direction. And 1, 2, 3, 4, 5, 6. The rise is 6. 1, 2, 3. The run is 3. And we can see that 6 divided by 3 here is just 2. So the equation of the line in slope-intercept form will be y is equal to 2x plus 3. Okay? Awesome. Awesome. Now, let us look on the next best practice. The point slope form of the equation of a line is a little bit different, right? Let us look at the point slope form. The formula for that is y minus y1 is equal to m into x minus x1, right? Where again, m is your slope, but x1 and y1 are simply just a coordinate. In this case, let's say it's the given point. So with this specific equation of a line, we only need the slope and a point. We only need the slope and a point. So to recap, if I'm writing the equation of a line and I have the slope and the y-intercept, then I use the slope-intercept form. But if I'm asked to find the equation of a line, I'm given the slope again, but now I'm given a point instead of the y-intercept, I will use the point slope form. Okay? So here, pretty straightforward again, like the first example, we're following y minus y1 is equal to m into x minus x1. So this will simply be y minus 5 is equal to negative 4 into x minus negative 2, right? Because this is x1, y1, and m. Notice how I made sure that right here I wrote x minus x1, okay? That's pretty much it. Y minus y1 is equal to m into x minus x1 here. And so y minus 5 will be equal to negative 1 over 4 x minus negative 3. And these will become positives. So it'll become y minus 5 is equal to negative 1/4 x plus 3. And that's pretty much it. Now, that is all that we are doing for the point slope form. Now let's analyze something else. And I want you to see the similarities between all of these. There's something that is very important to every single equation of a line. Here's your hint. This one says to write the point slope form of the equation of a line through the given points. Now, what you'll recognize is I was given 2 points or coordinates. 2 points or coordinates. Now, what two things do I need to write the equation of a line in point slope form? The two things I need are one, the slope m, and two, any point x1, y1. Now, remember point slope form, y minus y1 is equal to m into x minus x1, right? Now, if you should look, we don't have the slope, but we can find it. Because remember in our first lesson, y2 minus y1 over x2 minus x1. So in this case, we can label this as x1, y1, x2, y2. You guys did that yesterday. And simply go -1 minus 5 over -3 minus 2. And this will become -6 over -5. So our slope is just 6 over 5, right? And since we have our slope, what we will then do is we will pick any one of these coordinates to write the point slope form. What will that look like? Okay, so y minus, let's pick this first one. Y1 would then be 5 is equal to 6 over 5. That's your slope. That's your m. And you have x minus, and x1 would be 2. And this is your answer. Similarly, we could have done it using the second pair of coordinates and said y minus and y1 in this case, which is this y2, would be -1 is equal to 6 over 5 x minus -3. Because this coordinate is coming from -3, -1, where this is x and y. And this will be simplified as y plus 1 is equal to 6 over 5 x plus 3. These two are the answers here, right? You can use any coordinate because what is most important is that you're using the correct slope, okay? That's the most important thing to remember here. Now, this one says, write the slope-intercept form of the equation of a line through the given points. Now, we did point-slope form. Now we're looking at slope-intercept form, right? Remember, slope-intercept form is y is equal to mx plus b, and point-slope form is y minus y1 is equal to m into x minus x1. So kind of just speed walking through it, you guys see the difference here. This is slope-intercept, this is point-slope. Both of them use the slope. Slope-intercept, slope, point-slope, slope, right? Let's remember that. Now, to do the slope-intercept form of the equation of a line, we need to find the slope m. So let's do that here. x1, y1, x2, y2. And so y2, which would be 2, minus y1, 4 over 4 minus 0, be -2 over 4, which is just going to be -1/2. So that is our slope. Now, what I also want to point out here is, what is our y-intercept? Here's a clue for your y-intercept, specifically for this question. Your y-intercept is a coordinate where you have x is equal to 0 and y is equal to a value, because this is actually your y-intercept. So in this case, when they said 0, 4, it meant that 4b is your y-intercept, right? Think about it. If I have a graph and cuts the y-axis here, the coordinate for this point is that x is always going to be equal to 0 and y is going to be whatever value it is. So if I am given 2 points and one of them is 0 and some value a, I know that it is the y-intercept. That makes this question easy because I don't have to find it. Now, once I found my slope, I can simply say that y is equal to negative 1/2 x plus 4, and it's done. If I don't have it, then I have to then find my y-intercept, right? Now, there are a few ways to do that. We're going to look at the second example here, and I'm going to show you how I would find my y-intercept. There are a couple ways to do it. So first things first, let's find our slope, m, and that will be equal to negative 4 minus negative 1, right? I'm just earballing it here, guys, just to see if you are following. Then 3 minus negative 5. So what's that equal to? That's negative 4 plus 1 over 3 plus 5. So this will be negative 3 over 8. So that's my slope, okay? Negative 3 over 8. Now that I have my slope, I want to find my y-intercept. So what I will do to find my y-intercept here, let's look at best practices. The first way that I could find my y-intercept is by using the equation of the line. So I'd say y is equal to negative 3 over 8x plus b, right? And because what I'm looking for is b, what I would do to make it more straightforward is I'm going to substitute a y value and an x value. And so to do that, let us pick this one here, 3 and negative 4. It means that I'll end up with negative 4 is equal to negative 3 over 8, and the x value is 3, and this will be plus b. So I'll end up with negative 4 is equal to 3 times 3, which is negative 9 over 8 plus b. And now, to solve for b, I would simply just add 9 over 8 to both sides. That would cancel it there, and negative 4 plus 9 over 8 would be equal to b, right? And that's what I'm going to use to solve for b, okay? Now, you can use your calculator to do this. 8 4 is negative 32 plus 9 over 8. That's equal to b, right? And then we're going to simplify that. This would be 21 over 8. At least that's what I think. So that's how we would find b here. This would be negative 23 over 8. So my answer would be y is equal to, what's my slope? Negative 3 over 8 x minus 23 over 8. Okay? Now, again, this is m, x, and b. The tricky part is really finding b, right? Again, finding b, let's review this question here carefully. To find b, right, I simply said that if y is equal to mx plus b, because I'm manipulating to find b, let us substitute y, m, and x. So y we said was negative 4, m we said was negative 3 over 8, and x we said was 3 plus b, because we're using this coordinate. And all we did was simplify this. Negative 4 is equal to negative 9 over 8 plus b. Then I moved the 9 over 8 to the other side, and I got negative 4 plus 9 over 8 is equal to b. And if you use your calculators, you'll get negative 23 over 8. That's equal to b, right? Awesome.